In this lecture, we're going to talk about the discovery of neutron. Neutrons was discovered by James Chadwick, but before the James Chadwick, the Rutherford just gives a clue of another existing particle in an atom. How? Let's talk about that. Rutherford printed a clue of particle. How? He just took two hydrogen, which is equal to 1 proton and 1 proton, 2 protons are there. At that time, helium was also considered as the composition of the 2 proton. So, here the helium is also equal to the 2 proton. In that condition, these two elements should be equal. But when Rutherford just tries to make it equal, the helium just goes downwards and hydrogen just goes upwards. Now this proves that helium is heavier. But how? These consist also 2 protons and this consists also 2 protons. So how helium is heavier? At that point, the Rutherford said that there must be another particle consisting or existing in the atom. From there, the James Chadwick took a nuclear reaction in some of the rays and some of the elements to prove that is there another particle or not. For that he used nuclear reaction. As we know, if the nucleus of the atom is involved in any reaction, that reaction is called nuclear reaction. And if electrons are present or used in any reaction, that reaction is called chemical reaction. Now for this experiment, we need alpha rays and the beryllium. He just broke down the alpha rays and beryllium into protons and the individual particles as considered or as supposition. Just suppose as that time those people just thought that there are 2 protons in the helium and 4 protons in the beryllium. He just subtracted the 2 proton from the helium and got the number 2 extra. And he also just subtracted the 4 proton from the helium and he got the number 5. After adding 2 into 5, the number 7 would be taken or 7 would be the answer. But after just adding these two, like adding the proton into proton, he got the number 6. And after adding the 2 into 5, the carbon atom is formed but the atomic number is 6. That proves that the carbon atom must consist of the 6 proton and 6 individual particles. But here, when 2 is added to the 5, the answer is 7. So where is the another particle or another individual part of that? So when he just took an experiment, he just clears that when he reacted the helium or alpha rays from the beryllium, the carbon atom is formed, and after the formation of carbon atom, a type of a rays came out, and that's the neutron. He just gave the name of that particle as neutron. This is how James Chadwick just discovered the neutron. Now let's see how these experiments took place. Just consider neutron are bombarded from the electric field. Upward is the positive and downward is the negative. In the positive rays discoloration, the positive rays just bend towards the negative one, and in the cathode rays bend towards the positive one. But here, the neutron just passed out and just go to the detector and give here a fluorescence. The neutron just came here and joined here and give a glow. That glow is known as neutron. Now, fluorescence of both proton and neutron are equal. Because the mass of the proton is 1.675 and mass of the neutron is 1.678, there is a minor difference between it. There is a difference of 0.002. That is a very minor difference. So we're gonna just don't talk about that, or we will just consider the mass of the proton is equal to the neutron. Alpha rays are produced. Now how did we just consider the mass are both are equal? Because the fluorines here from the positive rays and from the neutrons is equal. That's why we considered the mass equal. Now here's a point. Alpha rays are produced by radioactive element or heavy gas elements. Now as we know how I can just got the alpha rays for the experiment, we can just get these rays from the radioactive element like polonium, radium, uranium. They just produces these kind of rays to become stable. Let's talk about the properties of the neutron. Identification. First, we're gonna just bombard these neutron from the electric field. Positive or negative, no charge, it will just pass out. That means there's no charge here. When we just bombard neutron from the magnetic field, south pole and north pole, it just bends toward the north pole, which proves that there is a mass here. Now, as we know that the ratio is equal to charge into mass. Here in the identification, we prove that neutron has no charge. So, because of that, because of no charge, no ratio EM would be considered. Penetration is high. Why penetration is high? Because we know the cathode rays or anode rays or many rays, the rays which has less penetration have more mass and charge. As we know that the neutron has no charge, so there would be no attraction and it would get more penetration or no friction would be happen. No ionization because of no charge. And that's all about today's lecture.